This is Shakil Ahmed. In this tutorial, we will discuss about making frequency tables for categorical variables. Basically, we want to summarize data involving categorical variables. So we start with importing our data on strokes. As when you open the Google Colab and with the new uh, notebook, if you want to create a new notebook, you can just go on file and then you can create your new notebook. I am just working with Google Drive as my files are uh, saved in Google Drive. Although you can directly sign in Google Colab and with your Google account, and you can create your uh, notebook drive, and you can also save your notebook in and attached it with GitHub. And whenever you change something, it will automatically update on GitHub. You can do via the GitHub guest. So these are some important things. Now I need the stroke data that is saved in my desktop. So you can just go here. Here is it. The arrow sign. Upload a session storage. This storage will be removed once you close the session. Then again you need to upload your data, but your notebook will be saved. So I have a stroke data and just open it, and then I need the pandas to import my data set and pt dot read csv and then stroke data, and then df with df head I can see first few observations of all variables. You can just click, and then you can see first few observations from all observations, and you can uh, convert this to a more interactive table, and you can see the suggested charts for each variable. If you want to display your data using graphics, we will discuss this later in a new video. Now we want to make a video, a table using tabulate package. So you need to uh, import the tabulate from tabulate package, that is called tabulate from tabulate import tabulate. So then you can create a list of categorical variables in your data set. I have just listed some variables. Although there is a command, you can just select all the categorical variables from your data set. But I did it manually. Then gender, your merit, and work type. These are categorical variables included. I want to make a frequency distribution for all these variables. Just want to make frequencies and then percentages. So you need to run a loop for variable. This is the vector I'm creating in categorical variable. So this will start from gender, and then your merit, and then work type, and then resident type, and then smoking type. So it will create as a table for each variable one by one. And then counts means you are creating the frequencies from this variable. It will vary for all variables. And then value counts, it means you will get the frequencies, and then you can normalize means it will be divided by its sum, and then multiply by 100, it means you are getting the percentages. And then you can make a table data, as you are putting the data in a data frame where the first variable is frequencies, and then uh, counts, and then percentages as frequencies. Basically you are naming frequency for counts and percentages for frequencies. although you can named here it here as percentages or something else. And then tabulate your table you have created with headers as keys. Keys means these are the keys, basically frequency and percentages. So let's see, you can just run it. It's working, and we have a frequency distribution for all the variables, for gender, and then for your merit, for uh, work type, and then for residence type, and then for smoking status. We have a number of numbers and then percentages. There were no missing values, so it's giving no missing values. Now it comes to two-way classification table where we have a row-wise variable and column-wise variable. Usually in health-related studies, we keep the outcome on columns and the exposures as rows. So uh, if we just want to check the gender association of gender with marriage status, so I am keeping your merit uh, variable as column and gender variable as rows. So you can see no, yes, and female, male, and other. There are three categories. So this will provide basically the percentages only. And if you want to create the uh, you want to make frequencies as well as uh, percentages, then you can follow the previous setup. You need to find the first counts, and then you can find the percentages. So here it's you are getting only percentages of the cells. So we can run. So uh, you are again tabulating the two-way table percentage row. I have just named these frequencies as two-way table percentage, and you are tabulating, and again we are keeping keys. And the table format is PSQL. If you don't give this option, you don't want to give this option, you will get tables like this. But in PSQL command format, you will get you are getting the it is in proper shape, and you can just copy this to Excel. And although you can make a data frame and can save to Excel, we will discuss this later. And then we can make a Fisher, we can apply a Fisher exact test to see whether there is an association between gender and marital status. So for this, you need to import the SciPy states that is used for mostly statistical inference purpose. And within this package, we have a Fisher exact library. So I just call this library Fisher exact. I have just imported this. Then we first need to create a two-way table. Just we did above. You can just repeat the cross step, and then two variables. You will get a cross step, and then using this cross tabulation, we can print the uh, the name of the table, and then we are applying Fisher exact test. So it will give odds ratios and p-values from Fisher exact on this table. You need to provide this table and then Fisher exact command. You will and what you want to get odds ratios and p-values, and then print your odds ratio as odds ratio. This is the text you want to keep, and this is what you are calling, and this is the text, and this is what you are calling the values. So then we can interpret the result using uh, based on p-value and comparing it to alpha, and your alpha is 0.05, and then you are giving an if else command. If p-value is less than alpha, Then there is a statistically significant association between gender and mental status. So you can write this way. And then else, if this is not true, then the result, the interpretation will be this. So you can do it manually, but if you want to just copy the results into your report, then you need to write these things in your code. That will be a good option. So just run this command and you will get the Fisher exact test that is giving an odd ratio of very low odd ratio, and the p-value is still significant, means there is an as strong, you can say, a negative association between uh, the categories of gender and your merit. You can say that there is a higher chance of getting merit in uh, females as compared to male. You can see here it's 63% in male and 66% male. And if we say no merit, then there is a 36% chance in male as compared to 33% in females. So these are all about describing a variables in categorical type of variables. In the next video, we will discuss about extracting variables and recording variables and handling missing values. So keep watching. Thank you.